Howdy doody, everybody. Welcome to our lesson on slope. It's our pre-chapter 012. So, we're looking at slope-intercept form today. And slope-intercept form we know is y equals mx plus b. That shouldn't be too unfamiliar to you. It should be familiar to you. And our m is our slope. Think of m for mountains. Mountains have lots of ski slopes. So that's how I remember it, mountains, slope. B is your y-intercept. And if you forget what a y-intercept is where the graph crosses the y-axis. So it's crossing the y-axis right there. That would be our y-intercept. Why do we use slope-intercept form? Well, it's easy to find the slope and the y-intercept, which makes it easy to graph. Our standard form is another form. It's ax plus by equals c, and in that case, the a, b, and the c must be whole numbers though. Why do you use standard form? Well, standard form can be easy to find the intercepts, the x or the y-intercepts. And also, word problems are also set up easily for standard form. All right, so we're going to look at a lot of different representations today out of this slope-intercept form. So the first example says sketch the graph of y equals negative 2/3 x plus 4. And we know that, again, the m, or the slope, is always in front of the x, and then our b, or our y-intercept, is that number by itself. So in this case, our y-intercept is going to be 0, 4. And again, notice how we always write it as an ordered pair. The y-intercept is always going to have an x value of 0 because you're not moving left or right. So we always plot that 0, 4, 4 first. And then slope is, again, rise over run. So it's 2 over 3, rise 2, run 3, but we have a negative. So that negative applies to the top or the bottom, but not both, because if you had a negative over negative, that make a positive slope. So we can go down 2, 1, 2, to the right 3, 1, 2, 3, and continue on, down 2, right 3. And make sure you put nice big points every time you do this. And then you can also do the opposite. So you could also go up 2, and then to make it negative, you'd have to go left 3. And you really should go in all directions. As we go to example 2, example 2 is now saying write an equation of a line that goes through 2 points. So what we have to do for that is this one, if you notice, it gives us 0, 5. And if we notice that the x value is 0, we should know that, oh yeah, the 5 is your b based off that. So that's your y-intercept, or your b. And then, if it's 2 points, we always want to find the slope. So I call this x1, y1, x2, y2, just like last lesson. So it's negative 4 minus 5 over 3 minus 0, which would be negative 9 over 3, or negative 3. And I know my b is 5 because, and only because, my x value is 0 here. So my equation becomes y equals negative 3x plus 5. As we go to example 3, now things change up a little bit, because if you notice, neither of our x values are 0, which means we are not given our y-intercept. And so the first step still stays the same. I'm still going to find my slope, x1, y1, x2, y2. And so I'd have 10 minus 4 over 1 minus a negative 2. And that would give us 6 over 3, because that becomes plus. 6 divided by 3 is 2. So I know my slope is 2, but I don't know my y-intercept yet, because I don't have my x value of 0, and that's what I have to figure out. So what we do is it says input one of the points in for x and y in y equals mx plus b, and you also plug in your slope. So again, here I'm using y equals mx plus b. I can use either point here. I like positives better, so since these are both positive, I'm plugging that in. So the 10 is going in for the y. The 2 is our slope. That's going to go in for m. Our x is 1, and then we don't know the b, so that's what we have to solve for. You could have used the -2 and the 4, but then you'd have to do 4 equals 2 times -2 plus b. You just have to make sure you use the x and y together. And so from there we solve for b, so this would be 2 times 1 is 2, and then I subtract 2 and get b equals 8. Make sure that you write your final equation. So it'd be y equals 2x plus 8 would be our final equation. You're not done until you write that equation. As we look at one additional, last one, it says sketch the graph of y equals 2x minus 5y equals 10. Now notice this is going to be in standard form. The y is not by itself. So that is our first goal. We want to write it in slope-intercept form, get the y by itself. So to do that, we do PEMDAS backwards. And remember, PEMDAS backwards means I'm going to undo addition subtraction first. So we subtract 2x from both sides. So I'd subtract 2x here, subtract 2x there. So I'm left with -5y equals -2x plus 10. Remember, these are not like terms. This -2x has an x, the 10 does not. So I cannot actually add them. I just write them as two separate terms. Then again, I want to get the y totally by itself, so I'm going to divide both sides by -5. And when I do that, these -5 would cancel, leaving me just with y. The negatives cancel out, so I just have positive 2/5 x. And then I have 10 divided by -5 is -2. And then I would graph that as normal. If I'm going to just make a quick sketch here, I would have my y-intercept at -2 here, 0, -2, and then I had to rise 2 and run 5. I'll make that 5. Rise 2, run 5. So it would look something like this. All right, I want you to try example 1 here, and then we'll have a question. All right, for example 1, it says write the equation and sketch the line with the information given. Your m is 3, that's your slope. So your equation would be 3x, and then your y-intercept is -2. So 3x minus 2 is your equation. Remember, your y-intercept is where it crosses the y-axis, so that'd be right there. And then you rise over run. I'd rise 3, 1, 2, 3, run 1, rise 3, run 1, and I also do the opposite. So I'd go down 3 and left 1. And connect those points, and you have your line and your equation. We're going to work on the other examples in class here. Example 5, try doing this one. You're trying to get this one in slope-intercept form, getting the y by itself. All right, again, we're doing PEMDAS backwards to try and get that y by itself. So I undo addition subtraction first. Again, I'm trying to get this y by itself. So I undo a positive 3x by subtracting 3x. And then I would divide by 2, everything by 2. So I would end up with y equals -3/2 x plus 7. That would be our equation. All right, we're going to try number 11 next, and that one says identify the slope and y-intercept of each line and then sketch the graph. So for number 11, if you notice, we are in standard form. So again, we have to get the y by itself before we do anything else. So I'm going to subtract 3x, which will give me 5y equals -3x minus 10, divide by 5, and our equation, which I'll put down here, be y equals -3/5 x minus 2. Our slope is -3/5. Our y-intercept is 0, -2. And when I plot those points, y-intercept 0, -2, I would go down 3, 1, 2, 3, run 5, 1, 2, 3, 4, 5. Again, the negative applies to the top or the bottom, but not both. And I could go up 3, 1, 2, 3, left 5, 1, 2, 3, 4, 5. And then make that a straight line. All right, number 16, we're going to do that one next. It just says write the equation for the line. So again, equation for the line equals y equals mx plus b. So y always stays as y, x stays as x. I got to find my y-intercept. That's probably the easiest. That's right here. That's at 5. So it's going to be plus 5 at the end. And then I have to find 2 points that my line intersects grid lines. So right there and right here. So I'm going to go down and to the right, 1, 2, 3, down 3. So that's -3 to the right 1. So my slope is -3 over 1, or just -3. So my equation would be -3x plus 5. All right, let's try 21. You're trying to find the equation line going through those 2 points. What makes 21 a little bit easier is that we are given 0, 2. And if you notice, 0, 2 is going to be your y-intercept because it's where x is 0. So you do have to find your slope. x1, y1, x2, y2. So I have 3 minus 2. So you know what? We're going to do the next one. So we'll do 22. So for 22, I'm going to go, I have to find my slope, x1, y1, x2, y2. I find my slope first, so 3 minus 3 over 0 minus a -2. And in this case, 3 minus 3 is 0 over 2. So that's a slope of 0. When I go ahead and plug that all into y equals mx plus b, because I need my equation, I pick one of my points. I'll just use this one. So 3 goes in for y. My m is 0. My x is also 0. And I put plus b. And so my b is 3. And since you could write y equals 0x plus 3, but 0 times anything is 0, so just y equals 3 would be your answer. And finally, finding x and y intercepts. Remember, y-intercepts are where it crosses the y-axis. So if you're going to draw a little sketch here, next to the y-intercept information, there is your y-intercept. It's crossing the y-axis. So to find the y-intercept, you write the equation y equals mx plus b form, and your y-intercept is the b. So if it's in slope-intercept form, it's just easy to say, oh, that's the b. However, if it's in standard form, it's usually going to be easier if you substitute 0 in for x. So basically what you always do is you set the opposite letter equal to 0. So to find my y-intercept, I set the x equal to 0. And it says always write your answer as an ordered pair. Why? Because it's a point on the line. It's a coordinate point. It is 0. This point is 0, -2. So to find our y-intercept here, so in this case, again, this one's in standard form, so I probably wouldn't rewrite it. I only use this b trick if it's in slope-intercept form. So again, you set the opposite letter equal to 0, so I'm setting my x equal to 0. And so I would do 0 plus 2y equals -8, which is just 2y equals -8, divide by 2, and y equals -4. So I'd end up with the point 0, -4. That is my y-intercept. Then we go to, oh, there we go. Sorry about that. So I plug 0 in for x. I added 2y to that. So plus 2y equals -8. I get 2y equals -8, divide by 2, y equals -4. And my y-intercept is 0, -4. You can also find x-intercepts. So again, x-intercepts would be where it crosses the x-axis, the line crosses the x-axis, or the graph crosses the x-axis. So that's your x-intercept. And like I said, you are going to set the opposite letter equal to 0. So to find the x-intercept, you're plugging 0 in for y. So to find my x-intercept, my y is equal to 0. So I'd have x plus 2 times 0 equals -8, or x equals -8. Again, write it as an ordered pair. So my x was -8, my y was 0. I'll do one more example for you. Example 2 here. Again, my y-intercept first is where I set x equal to 0. So I would have 2 times 0 plus 5y equals -10. 4 times 0 is 0, so I get 5y equals -10. And when I divide by 5, I get y equals -2. Again, write that as an ordered pair. The y was -2, my x was 0. You cannot combine the x and y-intercept together. Do not combine those -4 and -8 together. They are separate points. Again, 0, -2. If I looked at a graph, 0, -2 would be down here. It's on the y-axis. If I look at my x-intercept, that's where I set the y equal to 0. So I'd have 4x plus 5 times 0 equals -10. 5 times 0 is 0, so I get 4x equals -10. Divide by 4, and I end up with x equals 10 over 4, which is -2.5. And so, again, write that as an ordered pair, -2.5, comma, 0. And again, if you remember, -2.5 would be here, 0, that is where it crosses the x-axis. All right, you're going to try number 1 on your own right now, and then we'll practice the rest of these in class.